I always had a question. I bet most of you had too. How was the universe formed? There are many theories that suggest how the universe was formed, and one of it is the Big Bang Theory, which got me thinking. How can scientists test these theories? And I found out that to test these theories, scientists make explosions similar to the Big Bang. And to make them, we need particle accelerators and understand how they really work. English chemist John Dalton proved that elements must be made up of atoms, and 100 years later, it was proved that atoms are made up of protons, neutrons, and electrons. After a while, scientists were pretty sure that's how small matter gets, until they noticed cosmic rays from outer space. Cosmic rays isn't any cool superpower that people have in cartoons. They aren't rays at all. They're protons, neutrons, or electrons propelled by explosions from faraway stars. And some come from our own sun. When a cosmic ray hit an atom, it broke up into smaller pieces than protons, neutrons, and electrons, which showed that protons, neutrons, and electrons were made up of something else. So researchers started studying explosions, and to do that, they had to wait around until a cosmic ray could hit a tiny target, which could take a while. So they created machines that would create cosmic rays on demand, and the machines were called particle accelerators. You start by isolating a proton. When you isolate a proton, it carries a positive charge and is attracted to negative charges. When it moves, it reacts to the same way to electric fields, which means we can use the magnetic and electric fields to move and shoot it at a target. Electric fields based around the accelerator switch from positive to negative at a given frequency to make the particle move. When particles collide with light speeds, they create new particles. These explosions were not easy to see in microscopes, so scientists built new detectors. When an explosion happens, sensors detect the trail that the particles leave behind. Every type of particle only leaves that type of trail. Studying these trails tells a lot about the particle, like the particle's mass and more. So, an American physicist named Murray Gell-Mann said that these particles are called quarks and gluons. There's no evidence supporting this, but the math worked. Later, quarks were found in the Stanford Linear Accelerator. Like I told you before, particle accelerators can be used to create explosions similar to the Big Bang, which will help us learn more about the universe and how it was formed.